Anyway, right. I should frame this by, this is what he has asked for. So, hailing all the way from Oxford, weighing at least 3 kilograms, Rails Core's own John Leighton! Woo!
Oh my God. Okay, that's enough. Thank you! Are we back? Okay. The laptop just went dead. Okay. Hello. So the last time I gave this presentation was a week ago in a Ukrainian town called Dnipropetrovsk, and I practiced this word for ages and ages, and then I got up onto the stage, and I proudly showed all those Ukrainian and Russian people how I could say it, except that I messed it up. So this time, London. Thank you. Okay, so Tom, before lunch, kindly showed us how to make your code really fucked up. So I'm going to sort of riff on that and talk about refactoring. So I'm a member of Rails core, but a year ago I wasn't. I probably had, I think, 1 commit in Rails in the whole of time. But I decided that I wanted to do something. I wanted to contribute. And so I did the open source scratchy itchy thing. And I picked something that had annoyed me for a while, which was to do with through associations. So this is a standard through association that you've probably all seen, I hope. So we all know what that does. But what you can't do in Rails 3 is you can't do this. You can't say has many comments goes through tasks, because tasks actually is a through association itself going through projects. So this doesn't work. So I'd wanted this feature on a number of projects that I'd worked on in the past, and so I decided to implement it. And actually, I wasn't the first person to think of this. This is a screenshot that you probably can't see from the Rails bug tracker. Back in 2006, someone made a first attempt at this patch that was later turned into a plugin, and so on and so forth. Unfortunately, the plugin broke kind of every Rails release because things in Rails changed, and it was quite deeply linked to the Rails core source code. So I knew that I was, this wasn't a small challenge, but I was up for it, so I went for it. So I just want to talk about the problem a little bit. Here we have a model, a task model, which has many comments. This is an ordinary has many association. And there's a project model, which has many tasks. Again, ordinary has many. And again, an account model, which has many projects. On top of this, we can layer a through association. So this account tasks association links to the project tasks association through projects. Now, the green arrow here is what we call the source of the association. That's the thing that it is. And the red arrow, or brownie arrow, is what it goes through. So on top of this, I want to put the comments association on account to go through tasks. Now, this is a nested through association because it's going through tasks, which is already a through association. Still with me? So here's another example using the same set of models. This time, project has a comments association that goes through tasks, and account has a comments association that goes through projects. If we look at them side by side, the comments association on account is actually, it's the same set of records. And yet the data structure for setting up this association is different. So this is a bit of a problem, and I pondered it for a while and scratched my head. And actually, one of the reasons that the previous patches that had come before my attempt hadn't been merged is because they were quite complicated and doing lots of recursion and stuff like that, and it was really difficult to follow what was going on. And that was partly due to this problem that you can have different structures of associations that essentially represent the same thing. So I decided to look at it from another angle, and I had a look at the SQL that would be generated for this type of association. So it's quite simply select all comments, join to the tasks, join to the projects, and then where the account ID is whatever we need to be. But the thing to note is that this SQL is exactly the same for either of the two association examples that I've shown. And so I knew that I kind of needed to get from this complex thing into something more basic. And the thing that's obvious when you look at the SQL is actually just a linear data structure. I just need something that I can loop over and then spit out a bunch of joins, essentially. And so I can do this by, well, to step back, if you look at this, this diagram, it's basically a kind of upside-down tree diagram. And what I really want is the leaves of the tree, the bits that have no other nodes going off them. So I can do this by recursion, starting from the left, going into the source association. So from the comments on account, going to comments on task, and that's a leaf, so I can stop there, add that to my list, and go back up to comments on account, and into tasks on account, and then into tasks on project, which again is a leaf, so add that to the list, back up to tasks on account, and into projects on account. So in red here, we've got the list, select all comments, inner join tasks, inner join projects. So again with the other example, comments on account, into the source association to comments on project, and then into the source association to comments on task. Then back up to comments on project, and into the through association to tasks on project, back up, and then projects on account. Okay, so this is good because from two different tree data structures, I've managed to generate a list that is identical that can be treated in exactly the same way. I'm just going to have some water. Ooh. Totally smooth. Right. So let's look at, so use good data structures. Right, so this was actually, I mean, it seems simple when I show it, but I scratched my head about this for a while. And the key realization was that I had a data structure that didn't lend itself to the problem that I was actually trying to solve. And when I actually decided to transform that data structure into something that did lend itself to the problem I was trying to solve, it suddenly became a whole lot easier. So let's look at the code for that. Firstly, I want to say, what is a reflection? A reflection is metadata about associations. So if you have a tasks association on a project model, then the project model has a reflection object linked to it that has details about that tasks association, like the conditions for it, the foreign key names, etc. So this is a good place to generate that list. And I do it in a method called chain. And it's quite simply using recursion. So if it's a through association, then get the chain of the source reflection, add it to the chain of the through reflection, but the recursion has to stop somewhere, so for any other type of association, because it will eventually get to an association that's not a through association, unless you're doing some very strange things. So the base case is a one-item array that just returns self. So this is cool, and it works. But something that I realized about this, or something to realize about this, is that it's essentially saying, this code is saying, if it's one type of association, namely a through association, then do something. And if it's not, then do something else. We have language tools to solve this sort of problem, and it's called polymorphism. So if we have a specific type of reflection called a through reflection, then the chain method for that doesn't involve any logic. And it's just source reflection chain, through reflection chain. And then the general case of the chain for any other type of reflection, again, doesn't involve any logic. So it did occur to me, does this make sense, the fact that it's polymorphic beer? I don't know if I need to spell that out. So always think about using polymorphism. Quite often, a lot of logic in code is to do with, if I've got one sort of thing, do this, do that, etc., like case statements and stuff like that. And you don't always have immediately have the object hierarchies that allow you to immediately just deploy polymorphism. But it's something that's really important to bear in mind. When you see logic in your code, think about, is this comparing different types of things? And if it is, then if we use polymorphism, then instead of having that logic that we then have to test, we can just lean on the method dispatch in Ruby itself. So that was cool, and I worked out, I'd solved all my problems, so I hacked away. And it took a little while because, in case you don't know, associations are a little bit complex in Rails. There's stuff like polymorphism, polymorphic associations, and single table inheritance, and blah, blah, blah. And so I literally hacked on this for about 2 weeks straight. I was in between contracts at the time, so I just sat at home and wrote code. And my girlfriend started to wonder whether I'd gone slightly crazy. There were days at a time where I wouldn't leave the house. And anyway, hacking in the dark. So I hacked away, and I was like, yes, I'd done it. But it was a little bit painful to do because I was coming up against issues that I didn't really want to have to deal with. So in Rails 3, you probably heard of Errol, but the associations code hadn't been refactored to use Errol, so it was generating SQL strings and stuff. But I was trying to stay really focused. I was like, eye on the ball, John. You're not trying to fix strings or whatever. You're trying to do this one thing. And so I just sort of powered through, and I submitted this pull request. And the response initially was a little bit disappointing. Aww. The key issue was that my patch, it was kind of complicated, and it was adding this big new feature to Rails, and it was making the code more complex, and it was already really complex, and there were already lots of kind of edge cases and itty-bitty issues that hadn't been dealt with. And so it couldn't be merged at that time because it was only making things more complex. And the way I would describe this is that the associations code in Rails, I think, had suffered from what I call duct tape development. And this is the model of coding where you really want to get that one thing done, and so you just dive straight into the line of code you need to change, and you change it. And over the years, people slapping different bits on the side, you can imagine a project like Rails, loads of different coders would be changing that code, and nobody's taking account of the big picture and thinking about the big picture, and so the overall code base over time deteriorates. So I don't like to give up, so I just carried on, and I decided that I was going to refactor associations and then submit my patch after that. So I went, Rails was using Lighthouse at the time, and I went into Lighthouse and I found every single bug report about associations, and I categorized them. And I literally just went through and I fixed bugs, added tests, and did a lot of refactoring. So the rest of this talk is about some of that refactoring. One area of associations in Rails is the association proxy. And this is the object that allows you to do things like this. So task.comments.count, where comments is a association, will actually send a count query to the database, as opposed to sending a count method call to an array of objects. But on the other hand, if you do something like this, task.comments.map, then it will actually load up the comments from the database and then get that array of comments and call map on that array. So how does this work? Well, it uses our old friend method missing. A method missing does something like this. So loads up the target being that list of records, and then just sends the method on that list of records. So here's an example of the load target method. It looks something like this. Basically gets a scope and turns it into an array. So that goes off to the database. But sadly, I've made a typo here. It happens to the best of us. And so what's going to happen? Well, it's going to hit method missing, which is going to try and load the target, which is going to hit method missing and load the target and method missing, and it will carry on indefinitely. So the key thing here, and this is not something, this particular example is not something that affects end users of Rails, because hopefully when Rails ships, there aren't typos in the code. But as a developer, I came across this while I was trying to develop on the association several times, and it was very frustrating to try and debug. So the key thing to realize is that that object was actually doing two things. On the one hand, it was trying to be a proxy object and respond to method missing and pass things along. On the other hand, it had all the knowledge about how to load an association from the database, how to generate that scope, etc., etc. And so what I did is simply split it up into two parts. One is a very small object, the collection proxy object, which has the method missing. And if it hits method missing, then it has a reference to the association object, which is the other object, which knows about how to load the records from the database. But if I made a typo inside that load target method now, then there isn't a method missing definition to catch that typo, and so I wouldn't end up with this infinite recursion. So yes, it's a single responsibility principle. Does this picture make sense as well? Yeah. Okay. So it's a single responsibility principle, and we've all heard of this. But if I had a penny for every time that I saw an object that violated the single responsibility principle, I wouldn't be rich, but I'd be richer. But seriously, it's really important to think about all the time. It's not just something to think about when you're first creating an object, but objects often grow and evolve and suddenly become God objects, as we were talking about earlier. So, great job. On to the next part, the association preloader. This is the part of the code that allows you to do things like this. So this solves the n+1 query problem. So when I load a bunch of tasks, at the same time I load a bunch of comments, and then I don't have to load comments for every single task when I iterate over it. And it works something like this. Select all tasks, and then select a bunch of comments, and then link them up, the right tasks being linked to the right comments. So the way that this was implemented in Rails 3 was via a module called association preload, and that module was included into active record base. And inside that module were a bunch of methods. So I've drawn this diagram. Each node in the diagram actually represents a method in that module, and each arrow in the diagram represents a method call. So you can see the top method is calling 4 other methods, and from there on they're calling a bunch of other methods. And actually the very top one is the only method that is called from any other part of the association's code, or from Rails at all. So the rest of it is all internal to preloading. And you can see on the second level, it's basically splitting the problem up into the different things we have to do for the different types of association that we're dealing with. There has many, has one, has and belongs to many, and belongs to. And below that, there's a bunch of other methods, which they're all calling in various ways. And they're basically just shared code between those methods. So this was somewhat dissatisfying to me, and particularly when I looked at the method names. We can see that they're all prefixed with the word preload, and the method names are quite long. Yeah, it's not nice. So what did I do? Well, I turned it into an object hierarchy. And so the shared code on the bottom layer of the previous diagram now goes into the association abstract class, and there's also a collection abstract class and a singular abstract class. And below that is the actual concrete code for implementing the different types of associations, how to preload those different types of associations. So this was much better. It got all that code out of that module and into this other nice place, and I was able to have smaller methods, and that was great. And I've come up with a name for this type of refactoring. What is it? Yes. Yes, so I deployed object-oriented programming on the Rails code base. Definitely deserves a drink. Okay, so I just want to have a thought experiment. This is an arbitrary method that does some rubbish. It takes in a code parameter and it calls cleanup and colorize on it. And there's another way of writing this as an object. And I don't want to talk about which is better, because clearly the first one's better. But my point is here is that it really annoys me when people say, this method has to be 50 lines long. It just has to be like this. It never does. That's just simply not true. It's a case of working out how to extract it into another object, because a method simply encapsulates some work that needs to be done, right? And there's never any reason why that work can't be done in a separate object, why it has to be in a method. So on that note, I want to talk about the smells of object extraction. When to take a method and turn it into an object that does that work that's within that method. There are 3 smells. First one, long method names. So method names are basically, they provide a name for the work that that method does. And so if you've got a long method name, then it has to provide a lot of context for the work that's happening in that method. So when I see long method names, I wonder why is that context not provided by the object that the method's being called on itself? Is it because it should be in a different object? So from the preload code, we have this rather long method name. Preload has many association. And actually, preload is a namespace for what's happening. And has many is a subtype of the work that needs to happen. And so when I refactored this into objects, the namespace became a namespace, and has many became a subclass. And then the method itself was just 3 letters long, just run. So the second smell of object extraction is many or repeated parameters. So parameters are the state that you have to pass in a method to vary the type of work it does. And if you have to pass in lots of state, if you're passing around lots of state, or you've got lots of methods that repeat the same parameter names, the same things being passed through them, then I wonder, why is that state not stored on the object itself? Is it because that state is not related to what the object's doing? And if it is, then it probably means the method should actually be on a different object. So again, with the preload code, in that big module, there were 8 methods with a parameter named records. There were 7 methods with a parameter named reflection. There were 6 with a parameter named preload options, and 3 with a parameter named reflection name. Once I refactored it into objects, all of these things became instance variables and methods on those objects, which could just be called and did not need to be passed around all the time. And so that made the code that much clearer, because it remained, the parameters that were being passed to methods were focused on what that method was actually doing, rather than just passing around some state from one method to another. The third smell of object extraction is long methods with lots of variables. So when you're creating local variables in a method, you're essentially building up state that helps you get to that point of doing the final bit of work that the method actually has to do. And so my instinctive reaction when I see local variables is, why is this not a method? And sometimes the reason is that the local variable is not a method, separately, is because it's only relevant to this method that the local variable is being assigned in. Well, again, if that's the case, then why is this method here? Why can't it be in another object that has its own world, that can have its own methods of things that are relevant to the work that object is doing? Again, here's an example from from the preloader code. Don't try to read it, but seriously don't. But in red, I've highlighted all the local variables. And out of 15 lines of code, there's actually only 2 here that are not dealing with populating local variables. So when I abstracted this into objects, each of these local variables were able to just be their own methods, which are much more segregated, much easier to test, and the code became a lot clearer. So if you take one thing away, I'd like you to take this question away. When you look at a method that's non-trivial, please just think about, why shouldn't I refactor it into a separate object? Sometimes there are valid reasons, but often, there's just excuses. So don't make excuses. Ask yourself this question. So, so I finally got my patch in on the 22nd of March, 2011, about a week before my birthday. And so that was great, and I was happy. It took about 6 months. But I think the results kind of speak for themselves. So this is the size of the patch before I did all the refactoring. And as you can see, it was adding 877 lines, taking away 535, and so a net addition of 342 lines of code. Afterwards, it was just a net addition of 94 lines of code. So the complexity of the patch was reduced by a great deal, and that made it a lot easier for the core team at the time to review it, and made it a lot easier for it to be merged, and it made it much more obvious what was actually changing, rather than before, when there was just lots of code that was messing around with trying to, yeah. So, final points. I like refactoring, and I think you should too. Refactoring is a great opportunity to learn from the mistakes of others, because it's basically taking some bad code and making it better. There's a Beatles song a bit like that. Oh, come on, that was a lame laugh. Sorry. Seriously, like, writing good code is as much about reading books and stuff as just like studying bad code and trying to make it better and working out what works and what doesn't. And so it's a fantastic opportunity to do that. And you can't expect to write really nice code if you've never studied what made that code nice and why it might have been bad in the past. Secondly, consider the whole of your code base. A lot of us on a day-to-day basis probably work from some sort of bug tracking system where we go in and it's like, oh, implement this feature or fix this bug. And you just want to grab that thing, get straight in there, change the thing you need to change, and get the hell out and go to lunch. And that's cool, and we all need to get stuff done. But it's also really important to make time to just consider the whole code base and consider whether it's still coherent as a whole, rather than just always trying to dive into that specific line of code and change something. And finally, well, a question. Who here has heard of polymorphism? Okay, we've all heard of polymorphism. Who's heard of the single responsibility principle? Okay. So, right, so I'm kind of lecturing to the choir, really. But that's not the point, because the point is that you have to continually ask these questions. You have to continually think about that. It's not enough to just read books and know abstractly about things like the Liskov substitution principle and stuff. You have to actually actively, on a day-to-day basis, ask yourself these questions. And so refactoring is just about constantly asking your code, you know, hey, Mr. Object, are you doing too many things? Or that was really silly. Okay, so just to repeat this, when you see a non-trivial method, please think about, is there a reason it shouldn't go into a separate object? And if not, then maybe think about refactoring it. Thank you. Do I have time for questions?
Yeah, you do.
Okay. Yeah.
Has anyone got questions for John?
So a problem that I've seen reasonably often is that it's quite easy when using active record to accidentally create huge amounts of objects. It uses a lot of objects internally. Active record objects have a lot of state. They have these big object graphs inside. And I've worked on apps that end up having their performance degraded because Rails will just be pausing to do GC way too often. Have you found that introducing more objects has had a significant impact on memory use and GC time?
Okay, so for something like the refactoring of the preloader, that's not a big hit because it's really just generating one more object to do a specific bit of work that only needs to happen when you actually call task.includes or whatever. So, so what's my answer? My answer is no, not really. So with the preloader, I've added lots of different types of objects, but I'm not creating loads more objects. I'm creating one more object. But yeah, you're right. It's something to think about. But I would urge you not to prematurely optimize.
I'm up there.
How do you get product managers and clients to allow you to spend time and budget on factoring?
Well, I can think of two ways. One is don't tell them that you're doing it. And secondly, threaten to leave if they don't let you do it. Yeah, I mean, I don't have specific wise words about that, but I think there are ways, and I think there's not always a business case for, you can't come into a project and refactor everything, and you can't say, oh, I won't implement a feature until we've rewritten the whole thing. But, think about refactoring as a day-to-day activity.
Yeah, I was going to say there's a significant difference between a rewrite and refactoring something. You should be refactoring all the time, every day, every time you're doing part of a different task, doing some kind of, can I make this a little bit better, can I extract a class out? So you don't have to try and, obviously, you were trying to do a big redesign thing in isolation from your day-to-day work in Rails. You're working on something as a side project to try and refactor a whole big swathe of it, but from a business application point of view, you want to be. There might be a case where you're saying, well, in order to add our new version 2 API that a client wants, we're going to have to do some redesign on the way things work online, but not, if you hold everything back to saying, oh, we've got to stop 6 months for doing a big redesign, then you're going to be struggling.
So my thoughts on how you justify refactoring is got to go down to goals. You might have the most hideous code base ever, but if you don't need to change it, then you don't need to refactor it. So it's only when business requirements come along to change that you have to consider, okay, do I refactor and then do this feature, and what's that going to cost? Or do I just do this feature without refactoring, and what's that going to cost? And is there going to be, can you sell the end benefit to the business? If we do this refactoring, then the following work that we do on this code is going to go twice as fast or whatever.
Yeah,
it all comes down to goals, I think, is mine.
I agree with that. You know what you need to refactor because it's the code that you're touching. But at the same time, it's important not to put it off because you're just making the problem worse and building up technical debt.
But if you're working on it, that's the time.
Exactly, yeah.
We've got time for one more, if there is one more. Okay, one more.
Refactoring sounds good, but maybe you suffer some difficulties to keep current interface or existing interface or that kind of stuff. So can you share that kind of experience?
Are you asking specifically about Active Record?
Active Record or
well, there wasn't really, I didn't really have difficulties. I mean, there was some stuff that had to be deprecated and a few constants changed and stuff like that, but the outward-facing behavior of associations didn't really change. Although we did discover quite a number of cases where things didn't have tests because then people said, oh my God, this has stopped working. And I was like, yeah, I just changed everything and you didn't realize. But yeah, so I'm not sure, does that answer the question?
Yeah.
Okay.
Okay, big round of applause for
Thank
Tom.
you.